I recently purchased an EVGA RTX3090 FTW 3 graphics card for my professional 3D work, and I thought that you might be interested to know how much of an impact it makes upon poser use. Short answer, it's massive. I've been waiting for prices to normalise since they were first announced, and it was clear in 2021 that that was not going to happen until this year at the earliest. Now, finally, thanks to a number of factors, in the UK at least, we are starting to see cards at all levels coming in at RRP. And I must emphasise at this point that we are talking about manufacturer RRP, not NVIDIA's suggested retail price, the so-called MSRP. The MSRP is often considerably lower. One of the reasons why there is so much difference from MSRP and why there is such variation in card prices from manufacturer to manufacturer and from product to product is that NVIDIA produces a generalised GPU reference design. Then manufacturers can supply that in a range of configurations with different cooling solutions for overclockers and various base clock speeds and fans. I tend not to overclock hard, if at all, and I don't like the idea of water cooling, so the FTW seemed like a good choice. My reason for going with EVGA at all was the fact that they offer an extended warranty service. Generally, I'm not a fan of extended warranties, and while this card comes with 3 years as standard, I prefer to play it safe with such an expensive purchase and extended the warranty by a further 4 years for €240. I bought my EVGA FTW3 card from Scan for £1,958, and crazy though that price sounds, it was considerably short of the amount that they had been going for, if you could get a card at all. In the US, companies such as Best Buy have been hiding cards behind an additional £200 membership paywall, and even Scan pulled some early shenanigans requiring prospective purchasers to attend a special event in person. Anyway, a little shy of £2,000 was way more than I had envisioned spending when the cards were originally announced. My previous graphics card, the Titan X Maxwell Core version, is 7 years old now and cost £700 at the time, and was the most powerful consumer card available when I bought it. Back then I really thought I was putting on my big boy pants to spend that much, and I would never have dreamed that prices would escalate so far in such a short period of time. Happy to say I had many trouble-free and productive years with the previous card, and it paid for itself many times over until I switched to CPU rendering last year. Several factors affect render speed: the underlying technology, the GPU and GPU memory speeds, and the bus width. The amount and type of memory will also factor in, especially as scenes get larger. But one factor that trumps all of those is the number of simultaneous streams of data that can be processed at once. On a CPU, you can think of it as being defined by the number of cores. On an NVIDIA GPU, you can think of it as the number of CUDA cores, although the two are definitely not directly analogous. CPU cores can do far more work per cycle, but CUDA cores come in massively greater numbers. To give you an idea, Intel's latest CPUs come with a mixture of cores, some performance and some efficiency. The latter offer lesser performance for less demanding tasks. The flagship i9-12900 has 8 efficiency cores and 8 performance cores, running at a base speed of 3.2 and 2.4 GHz respectively, although they can increase by at least 70% with turbo. The gaming sweet spot in terms of price to performance is the i7 with 8 performance cores and 4 efficiency cores. I'm not sure that CPUs where a third to half the cores are less effective makes much sense for rendering, where every tiny bit of performance matters. My CPU is the AMD Threadripper 3960X, which has 24 full performance cores, each capable of running 2 threads per core at 3.8 GHz, although mine are safely and conservatively overclocked to 4.4 GHz using the motherboard's auto overclock feature. I purchased the original Titan graphics card for its 12GB of GDDR5 memory and its 3072 CUDA cores. The new RTX3090 has 10,496 CUDA cores and 24GB of GDDR6X memory. To be honest, I don't create a lot of scenes that even come close to the Titan's 12GB memory limit, let alone 24 gigs. But I think whenever you are upgrading hardware, you should build in as much headroom as possible within your budget. Today's excessive, quickly becomes tomorrow's adequate. Personally, I find scenes that include a lot of background plants can quickly ramp up the memory requirements. But how much difference does the 3090 make to poser use, and why? Well, at its best, it's more than 280% faster than my powerful 24-core Threadripper, and almost 650% faster than my Titan X, both of which were already excellent products in their day. In a world where we're used to processor performance improvements of 10 to 30% from generation to generation, that's the kind of performance improvement that you really notice. Admittedly, my Titan is 3 generations old now, but it was still serving me well for everything but rendering. In Poser there are 2 GPU drivers, a basic card driver and one that uses the Optics engine. Optics is a pipeline for ray tracing provided on NVIDIA cards. Pipeline means a sequence of processes designed to provide real-time ray tracing. Although this technology is designed primarily for games, it also provides significant benefits for Poser rendering. Older cards do not provide optics support, which was introduced in 2009. The 24GB of RAM also tends to make the card better suited to creative users rather than elite gamers, who are better served by the 3080 or 3080 Ti. I tested using the same scene at a size of 3080 by 1664, aiming for the same end quality, and with post-processing Intel denoise turned off. On the CPU that meant pixel samples of 5 and branch path turned on with a bucket size of 64. On the GPU I turned pixel samples to 10, branch path off and ramped the bucket size up to 1000. These settings will change according to the amount and type of light in the scene, and you may need to set the GPU samples to 15 or even 20 in some circumstances. I will at this point just mention something that at first seems odd. Given that Poser detects whatever hardware you have connected, why does the program offer both optics and non-optics drivers when you clearly want the more powerful optics option? The answer I think comes down to an excellent Poser feature, namely its ability to utilize multiple cards at once for even faster rendering. The one caveat is that you must use the same rendering method for both, either optics or non-optics, and therein lies a critical consideration, which is best clarified with some actual numbers. Using the CPU renderer, I rendered the test scene in 207 seconds on my old dual Xeon E5-2687W workstation, and in 194 seconds on the Titan X. Switching to my current 24-core Threadripper CPU, I rendered in 76 seconds. With the non-optics GPU driver on my 3090, that time was reduced by 24% to 57 seconds. However, using the optics drivers, the time fell by a massive 64% to just 27 seconds. That means that it was almost 3 times slower to render using a high-end CPU than the GPU. However, it also means that using optics even on the same card is more than twice as fast as non-optics. With that in mind, if you have 2 otherwise similar cards in your machine, and one of them is non-optics, you'd get better performance using just one card with optics drivers than 2 without. I realise that giving render speeds using exotic server and prosumer processors does not provide numbers that you can necessarily compare to your situation, but without having the same test scenes available to you, this is only indicative of my personal experience in any case. There is another area where you'll notice an improvement, although it's impossible for me to precisely quantify, and that's during scene navigation. Poser uses the OpenGL API. Think of it as a 3D language for converting your scenes into a visual image as you work. This also uses the GPU, and you'll notice it as you move around your workspace. I'll be honest, while I did notice an improvement over my previous GPU, on a scene with 8 fully clothed figures, plus props and lots of flowers, while the scene was easier to navigate than on my previous card, it was far from silky smooth, even with the display set to wireframe for speed. With the Titan, rotation must either be performed extremely slowly, a few degrees per second, or else it jerks around in a series of large 90-degree steps. With the 3090 the display does update quickly enough to be useful, but it was still painfully slow. If this is simply down to inadequate optimization, it's something I'd love to see Bondware take on. Incidentally, even this scene, unwieldy as it started to become, only utilised 10.743 gigabytes of the card's 24 gigabytes of memory, making me wonder if maybe you'd hit a navigability ceiling before you came anywhere close to the memory limit. So in conclusion, do I recommend a 3090? Of course, the size of your budget and the frequency that you render will be considerations. The size and complexity of your scenes is also a factor. I often final render everything at 4K, and I turn the render settings up to the point where turning them up further makes no visual difference. For me, time is money, but importantly it affects my creativity. If I can push out a high quality test render in under a minute, that encourages me to try variations, usually different camera positions and lighting configurations, and that is only ever a good thing as I attempt to improve my craft and my products. It also means that I can take on animations, knowing that I will not lose the use of my machine for weeks at a time. For you, if you have deep pockets or can justify the financial expenditure, I would say that you will likely see a significant improvement, even compared to the previous generation's flagship graphics card, the 2080 Ti. The 3090 offers a 35% performance jump. I will also mention that NVIDIA has announced a Ti version of the 3090, which will have even more CUDA cores, and early indicators suggest it will be 10 to 15% faster still. Pricing has yet to be announced, but it has been listed in Taiwan for the equivalent of £4,000. It's a pity that Poser cannot fully utilise both optics and non-optics cards simultaneously, or even use the CPU as well for maximal performance. That minor software limitation aside, I couldn't be happier with my new card.